All right. Next.
Are going to start to get more interesting. We are going to talk about
Oh, baby.
data modifiers.
These
So
bad
let me show
boys.
you what
Cool.
I'm going to do now. I'm going to use the color mapper to do something
Wait. Okay.
very specific, to change the color of a single particle. Let's create a basic emitter, and let's go to the emission mode and shoot only.
Wait, hold on. I gotta delete everything. Why doesn't it delete? Okay. Bam.
One particle. That's it. I'm
One.
gonna set my emitter size to 0, 0, 0, just to make it a point. And
Give me a second. One particle. What'd you set to 0, 0, 0? Size. I can't change my Z.
if I press play, you will see one particle is just missing.
Wait, no way. All right. Keep your eyes peeled. There he goes. Oh, okay.
Moving that way. Now this is a bit too small.
Wait, how come I have a line of them? He only gets one. Is that because of the 0? Oh, shot. Hold. Wait. No, go back, go back, go back. He's the only one.
More, and my timeline doesn't have enough frames. I'm going to go to my particle group, go to the draw tab, and let me increase the radius to 4 so we can see it.
Oh shit.
Rewind, and you can see the
Oh shit.
Excellent. So this is just a particle that is traveling.
Wait. Wait. I want him to come back. I find that very funny.
On the z axis. The color I want this particle to be originally, let me rewind, I'm going to go to the basic emitter, and that color is
Properties.
set in the properties, go to the color tab, just twirl it down,
Are you? Yeah, you're an emitter.
and use a constant color. I'm going to set this to red, 100% fully saturated red. So now my particle is going to be red. Excellent. What I want to do now is when the particle reaches approximately 60 frames of age, I want it to start changing color. And the way I'm going to do this
That's cool.
is using a color mapper. So let me add a color mapper, and let's make it a child of the particle group. Now,
Holy
it wouldn't
shit.
make a difference in this particular setup because we only have one particle and one particle group.
Right.
This is a good habit you need to start developing,
Right.
just in case you add other groups further down the line and you forget which one applies to which. So it's good to keep any modifiers
Is this
that
just a
apply
color
only
ramp?
to certain groups as children of those groups. What this color mapper is going to do is the following. It's going to use a property as
What
a
the
source.
fuck was that?
And that property is going to be the age of the particle.
Ah.
When the particle reaches an age of 60 frames, because that's the frame number, the 2-second lifetime mark, and up until it becomes 3 seconds old, then I want these colors to map to this particle, and after 90 frames, it's going to continue with the last color over here. This is what it's saying. It's very simple. Again,
Age.
take the age of the particle. When it reaches
60.
and all the way to 90 frames, so from 2 seconds to 3
Why are you not doing that?
seconds of its age, I want you to just go through
Oh. Lower 60, upper 90, and 90.
this gradient and change the color until at
Red,
90
yellow,
blue, and then it's going to
low
remain
blue.
Let's see if that works. Rewind, press play, and it's
So
going to
red.
change color, and now it's blue.
Red,
So we are mapping
lighting.
a particular property, one of all these properties.
Oh wow.
to a particular other parameter, which the
God, this is gonna get
allows
so
us to do
complex
that with a
so
gradient
quickly.
or various other things. It has noise and so forth. And we can use fields, and there's a lot of stuff we can do to map these things. Now, another thing I can do is I don't want the age to map to a color. I want the position z. So as the particle moves in z direction, depending on the value of its z position, we can change this gradient.
Easy.
So just go to property and find position. And when we have these sorts of properties that have many components, you can select the x, the y, the z, the magnitude of the position, so how far away it is from the origin of the emitter, or the dot product, and this is for more fancy stuff. In this particular case, because it's moving in the z, whether we use magnitude or z, it's the same thing. I'm going to use z. And now our unit has changed from frames to centimeters. So from 60 to 90 centimeters, the color is going to go from red all the way through the gradient out to blue. So let me rewind, press play, and you'll see, there you go. That was very, very quick. So let me set this to 500. So as you can see, it's changing color, and
What? 60 to 500. Launch it. Okay, bud. Why? What? $60 centimeters to 500 centimeters. Didn't touch this. Position Z. He has a smooth curve. Mine's X'd out. Okay, we have the exact same settings. Mine's not doing that. Mine is. Mine's blue by 60, dude. What the hell?
approximately 500 centimeters from the origin, which I think is over here, it turns to blue and then it continues its life. Now, the great thing about this is that it doesn't matter how many particles
I don't know.
or where they are going. And let me show you exactly what I mean here. I am going to change my basic emitter to emit from a sphere. I'm going to make this sphere 20 and 20 and 20, and I'm going to shoot more than one particle. I'm going to shoot 1,000 particles per second. Rewind, press play, and watch this. Only the particles that
Oh, wait, no. 0, count. 1,000. Per second? Shot, constant, pulse? I don't fucking know what that means.
are moving in the z
Ah.
direction are changing color. And they're changing
Whoa.
color depending on how much
Dude.
they are moving.
That's sick. Wait, I need more. I need more.
So now you can see some interesting things happening. And it's a good opportunity to show you the
Constant.
difference between
Per second.
the z position, which is in one direction, or the magnitude. So I'm going to set this to magnitude, leave all the other parameters.
Excuse me, son of a bitch. Give me 1,000 per second. Dude, look at that. Wow. Oh, I see what you can do here.
The same. And what's going to happen here is that particles that are away from where they were generated, 60 centimeters up to 500 centimeters, are going to use this gradient. So we're going to see a radial change of color.
Whoa.
Red, and then we're going to
Wait, I wasn't paying attention. What'd you do?
and it's a good opportunity to show you the difference between the z position, which is in one direction, or the magnitude. So I'm going to set this to magnitude, leave all the other parameters the same, and what's going to happen here is that particles that are away from where they were generated. 60 centimeters up to 500 centimeters are going to use this gradient. So we're going to see a radial change of color. Red, and then we go. Into the yellows and then go into the blues. And what the color you see here is the override color. We haven't used the viewport override. This is the color that the particles are going to use to render. So if I want to make this a bit more fancy, let's just create a turbulence, let's change the parameters to something, and let's go to our basic emitter and say we want to go nuts and generate a million. Is it a minute? 100? Nope.
Wait, chill. Slow down, I'm confused. Simulate, force, turbulence. What did he say? Like this, and this? Is that the triangle that he wanted, or was this the triangle that he wanted?
Right. This is the color that the particles are going to use to render. So if I want to make this a bit more fancy, let's just create a turbulence, let's change the parameters to something, and let's go to our basic emitter and say we want to go nuts and generate a million. Is it a minute? 100? Nope. I want to make it a million. A million per second. And press play. And we're getting all these particles, and you can go and render them. Excellent.
That's so... Wait, hold on. This might crash. Good luck. That's so cool.
I'm going to leave it as it is. I'm going to pull up my redshift layout and press start, and you will see the colors of particles appear in your render view. There they are, and we have this nice colorful particle simulation.
Wait!
I think it's a
Wait, we have to do that. That looked so cool. Right, we see blue. Watch this, watch this, watch this, watch this. Yo! Dude, that's sick. Give me more turbulence. Give me like way more turbulence. So all you see is blue, but if you go to render... Oh, that's so sick! Oh, dude, man, this is cool. It's just pixels. That's awesome. That's... This is so exciting. Cool, one more down.
It's a good time.
But I want to see that again. Wait, I want to let it play. Fill this screen up with dots. There. Oh, man. Man, that is cool. Dude, we're going to be able to make some really cool shit with this. That's awesome. Cool.